Welcome to this explainer. Today, we are grabbing our tools and conducting a full-blown archaeological dig into the Cambridge Assessment Framework. We are uncovering the examiner's absolute top secrets to finding solution sets for quadratic inequalities. Look, if you are studying for the Cambridge Additional Mathematics exam, specifically syllabus code 0606, you already know the stakes. The clock is ticking, the pressure's on, and the difference between getting a B grade and that coveted, elusive A star often comes down to mastering one very specific, highly technical skill. We're talking about finding the solution set for quadratic inequalities, either graphically or algebraically, and writing it out in the exact perfect form. Think of a solution looking something like -3 is less than x, which is less than 6. Sounds simple enough on the surface, right? But here's the crazy part. Examiners repeatedly report that this specific topic is a massive stumbling block for thousands of candidates every single year. So today, we are going to look at a real Cambridge Mathematics past paper question. We're going to follow two hypothetical students taking this exam. We've got Alex, who just overloads his paper with raw math facts but completely skips the analysis. And then we have Sam, who rushes through the paper in a panic and totally misses the command word requirements. We're going to put their flawed answers side by side with the red pen marks, and layer by layer, we are going to excavate the hidden clues to reveal the flawless answers that secure every single method mark available. Let's get into it.
Here is our game plan for today's dig. First, the A-star difference. Second, deconstructing the question. Third, the method mark strategy. Fourth, our interactive workshop. Fifth, top examiner warnings. And finally, number 6, your success blueprint.
Section 1, the A-star difference. Analyzing the assessment objectives.
Okay, let's look closely at how top-tier candidates separate themselves from the pack. The Cambridge Additional Mathematics Framework doesn't just want to know if you can blindly factorize a quadratic equation like a robot. They are actively prioritizing analytical depth over superficial breadth. Let's compare the flawed approach with the flawless approach. On the left, we have our student Alex. When faced with a quadratic inequality, Alex just panics and starts throwing every raw math fact he can think of onto the page. He factorizes frantically, scribbles down some numbers, prioritizes superficial breadth, and completely ignores the underlying logic. And our other student, Sam? Well, Sam just rushes. Sam reads the question way too fast and totally misses the specific command words the examiner deliberately placed there. Both end up losing massive marks. But on the right, we have the flawless approach. This top-performing student demonstrates a connected, conceptual understanding by using what we call the Peel framework, perfectly adapted for high-level mathematics. That stands for principle, equation, execution, and logic. First, the principle, identifying the exact inequality type. Second, the equation, finding the critical values by treating the inequality as a standard equation first. Third, the execution, actually sketching a graph to visually understand the regions. And finally, the logic, logically linking that sketch back to the original inequality to state the final mathematical range. That structured reasoning is exactly what examiners are hunting for. Before we continue, subscribe to our YouTube channel Ace the Exams at AC Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Now, what's really fascinating about this table is how it breaks down the specific cognitive domains examiners use to measure your true mathematical mastery. This isn't just about magically arriving at the right numbers. It is entirely about how your brain processes the problem on the page. The first domain here, knowledge and understanding, is your baseline mastery of fundamental principles. Can you successfully factorize a quadratic? Can you find the critical values? Awesome, but that's just step 1. Then we step up to the application domain. This requires transferable conceptual understanding. For instance, if a question gives you the area of a rectangle expressed as a quadratic formula and tells you the area must be greater than 20, can you step up and set out the inequality yourself? And finally, we have analysis. This is the big one. This is where you demonstrate logical reasoning and true analytical depth. It involves sketching the curve, identifying whether you need the region above or below the x-axis, and formatting your final solution set impeccably. You literally have to hit all 3 of these domains to unlock those full marks.
Section 2, deconstructing the question, the procedural framework. Look, before your pen even touches the paper to start calculating, you have to follow this standardized, systematic sequence. Let's do a live rewrite here and turn Alex and Sam's red pen marks into green check marks. Step 1, deconstruct the question. This is where Sam went wrong by rushing. You have to ask, are they commanding you to solve graphically or algebraically? Circle that command word. Step 2, extract relevant data. What exactly is the inequality? Is it greater than or is it strictly greater than? That one tiny detail changes everything about your final format. Step 3, select your analytical framework. Are you dealing with a positive quadratic, that classic U shape, or a negative quadratic, which gives you that N shape? Step 4, execute with clear notation. By forcing yourself to go through this sequence, you completely eliminate those silly, rushed errors, and you ensure every single step aligns with the examiner's grading rubric.
Section 3. The Method Mark Strategy. Process over final answer.
I literally cannot stress this enough. In Cambridge Additional Mathematics, a magically correct final answer with 0 working out will very often score you an absolute 0. Nothing. Examiners use a grading system heavily weighted towards method marks. They want to see the pure architecture of your thought process directly on the paper. Let's walk through this exact deconstruct, solve, and evaluate methodology. Imagine you are given the inequality x squared minus 3x minus 18 is strictly less than 0. Step 1. Identify the given info. Step 2. Break it into logical steps. You find the critical values by temporarily setting that expression to equal 0. You factorize it to get x minus 6 times x plus 3, which gives you critical values of positive 6 and negative 3. Step 3. Solve systematically. You draw a quick sketch. You sketch your positive U-shaped parabola intersecting the x-axis at negative 3 and positive 6. Now, since the original inequality was strictly less than 0, you are visually looking for the exact region of the curve that dips below the x-axis. Step 4. Check for reasonableness. Does your visual sketch actually match your algebraic logic? Yes, it does. And finally, Step 5. Make your justified recommendation, which means writing down the final solution set perfectly.
And here is that perfectly written format. Negative 3 is less than x, which is less than 6. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, getting back to this slide. This single line of text is where literally hundreds of students drop their final accuracy mark every year. When the solution is a single continuous region sitting right there between 2 critical values, you absolutely must present it as a single compound inequality. If you write x is greater than negative 3, comma x is less than 6, you are probably going to lose the mark. The presentation of information in this syllabus follows incredibly strict conventions. Proper terminology, appropriate formats, and crystal clear notation are just non-negotiable.
Section 4. Interactive Workshop. Extracting the Core Trend.
All right, it is workshop time. Get ready, because I am putting 60 seconds on our imaginary clock for a data scan challenge, and then we are going to find the flaw. Let's say a student correctly factorizes an equation for the flight path of a projectile. They do all the math right, and they find the critical values for time, represented by the letter t, at -2 and +5. The inequality asks when the projectile is above a certain specific height. Mathematically, the raw data says the region is perfectly between -2 and +5. So the student writes, -2 is less than t, which is less than 5. Why does this lose a mark? I'll give you a second to think about it. Spot the flaw. Have you got it? The fatal flaw here is that they provided a generic, robotic mathematical answer that completely ignored the physical context of the question. You can have negative time. Time cannot be a negative value in this physical scenario. So the actual perfect examiner-approved answer must be 0 is less than or equal to t, which is less than 5. You always have to extract the core trend from the specific context you are given. Now, as a speed writing challenge, I want you to imagine writing out one perfect PEEL paragraph explaining that to an examiner. Principle, equation, execution, logic. Boom.
Section 5. Top examiner warnings, avoiding the pitfalls. Now we have to brush away the dust and examine the principal examiner reports. Every single year, Cambridge publishes these reports detailing exactly where candidates crashed and burned. We have isolated the 3 most devastating pitfalls specifically regarding quadratic inequalities. The top mistakes are confusing cause and effect, forgetting the strict format conventions, and providing generic answers. Let's break these down so you don't make them. Confusing cause and effect often means students find the critical values, say 2 and 5, and if the original question was greater than 0, they just blindly write x is greater than 2 and x is greater than 5. No, they completely miss the structural reality of the graph. You absolutely must sketch it to see that the greater than regions are actually on the outside tails of the parabola, heading in opposite directions. The second major pitfall is forgetting format conventions. That means using the wrong inequality signs, or writing the word and when it logically has to be the word or. And finally, providing generic answers. This goes right back to our projectile motion example. Or imagine the math gives you a negative dimension for the width of a garden. You have to analytically, logically discard that negative value in your final presentation, because a garden can't have a negative width.
And look at this quote directly from the examiners themselves. They state explicitly, the classic mistake is providing generic answers not specific to the question context. always link every point to the given scenario. They are begging you to pay attention to context. Context is quite literally everything when evaluating graphical or algebraic solutions. This is the absolute pinnacle of the evaluation domain. Higher-order assessment objectives absolutely demand that you evaluate the algebraic alternatives, compare your mathematical output to the physical reality of the scenario, and make a highly justified recommendation for your final solution set. When you do all of that, you are proving absolute undeniable mastery of the subject.
Section 6. Your Success Blueprint, the final system.
Okay, let's consolidate all of these excavated clues into a final bulletproof system that prioritizes logical, structured reasoning. We are talking about 3 golden rules: command word decoding, Peel framework application, and the time management matrix. When you hit a complex quadratic inequality question in the exam, you generally have an average of about 8 minutes to secure full marks. Here is your time management matrix. Minute 1, command word decoding. You are purely extracting data and interpreting the relationships. By minute 3, you select your analytical framework and apply your Peel principles. Are you solving this algebraically by completing the square, or are you sketching a graph? Make the call. By minute 6, execute systematically. Show every single step of your working out clearly to lock in every single method mark. And in the final 2 minutes, hitting minute 8, present your answer in the correct format, checking your logic against the physical context. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
You've seen exactly what the examiners are desperately looking for. You now know exactly how to structure your answers, how to sketch those curves with confidence, how to properly identify critical regions, and most importantly, how to formate your final answer to secure those top-tier marks. The tools to decode these complex problems are now completely in your hands. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
Remember, whether you are solving graphically or algebraically, highly structured reasoning will absolutely always win over superficial memorization. The next time you look at a quadratic inequality, I want you to ask yourself, are you just blindly shuffling numbers around like Alex, or are you truly analyzing the reality of the curve? Keep applying this exact blueprint. Never forget to verify if your mathematical answers actually make sense in the real-world context of the problem, and keep that curiosity alive as you uncover the deeper logic behind the mathematics. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.